So we have this grinding wheel. It's initially at rest. Is rotated with a constant angular acceleration of 5 radians per second squared for 8 seconds. The wheel is then brought to rest with a uniform acceleration at 10 rests. So it's going to accelerate. It's going to go to a certain velocity after 8 seconds, and then it's going to come to a rest. So now we want to talk about the slowing down of the wheel. Okay? So there's two motions. There's the speeding up and the slowing down. Speeding up and then slowing down. Let's talk about the slowing down part here. Okay, let's look at the variables here. Now, the slowing down part, it's brought to rest, so we know it's going to end with 0, and we know it's going to take 10 revolutions. Now, 10 revolutions is an angular displacement, right? But we want it in radians. So 10 revolutions, it's how many radians per revolution. Every 1 revolution is 2 pi radians, so it's going to be 20 pi that we're going to use for the angular displacement. We know it comes to a rest. We know it's a uniform acceleration, but I don't know anything else, and I want to know what's the angular acceleration. Yeah, I want to know this quantity. I need to know one other quantity. So I either need to know how long it takes, which they don't tell you. This 8 seconds is for the speeding up part. They don't tell you this, but they tell you, but we need to somehow know what angular speed it started with. So for that, we can look at the speeding up portion. Before then, what happened? How did we get to this point? Okay? Because basically the final angular velocity of the speeding up portion is going to be the initial angular velocity here. So the speeding up, it starts at rest, okay, as an angular acceleration of 5, and it takes 8 seconds, and I want to know this guy right here so I can plug it in to the initial angular velocity for the slowing down. So we're going to use this equation, and that's going to give you 0 plus 5 times 8, which is 40. So this is 40, and then that makes this 40. And now I have 3 quantities, and I can use what equation relates those 4 variables is this one. Right? And so then we have 0 squared is equal to 40 squared plus 2 alpha times 20 pi. And then we can solve for alpha here. So that's going to be 40 squared divided by 2 divided by 20 divided by pi, and I get negative 12.7 radians per second squared. Okay? Determine the time it took to come to rest. So now I know this quantity, I want the time. Well, rather than plugging in this number, you could just say, well, what equation relates the 3 knowns and the time also is going to be this equation. Okay, so it's going to be 20 pi is going to equal 40 plus 0 divided by 2 times t, which is 20t. And so you can solve for t. T is about 3.14 seconds, about pi seconds there. Okay.